All right, we've spent enough time talking about the theory of AI. But theory is just the map. It's not the actual journey. Today, we are leaving the map behind. We're going to get our hands dirty, moving from abstract ideas to actually building something. In this explainer, we are going to perform the practical ritual, and from scratch, we will summon our very first artificial neuron. So, here's our game plan. It's a 4-part journey. First, we'll forge the workspace. That's our digital altar. Then comes the incantation, the Python code that's going to wake this neuron up. After that, the invocation. This is where we run the code and actually see it learn. And finally, we'll get to the heart of it all, the mathematical soul, the simple, beautiful equation that makes it all tick. Okay, let's get into it.
Before you can start any kind of ritual, you have to prepare the space. It's no different here. To bring our neuron to life, we've got to set up our digital altar. And the good news is, it only requires 3 essential things. That's it.
First up, the vessel. That's Python itself. Just head over to python.org, grab the latest version. Now listen, this is absolutely crucial. During the installation, you have to check the box that says Add Python to Path. Trust me, it'll make your life so much easier. Next, you need a Scribe, a clean, simple text editor. VS Code is great, but honestly, even Notepad will do the trick. This is basically your digital quill and parchment. And finally, the altar, your command line or your terminal. This is where we'll actually issue the commands to bring our creation to life. Okay, once you've got those 3 things ready to go, open up your altar, that terminal. Just type Python-version and hit enter. If you see a version number pop up, something like Python 3.11.4, then, hey, congratulations. Your workspace is forged. The stage is officially set.
All right, it's time to write the incantation. Go ahead and open your Scribe, your text editor, and create a brand new file. Save it as perceptron.py. The words we're about to type, in this very specific order, are the code that will awaken our neuron.
So, what are we going to teach this newborn mind? Something really fundamental, the logical AND gate. It needs to learn a simple rule. Only when both of its inputs are true, or 1, should its output also be 1. Any other time, the output should be 0. It might seem like a simple task, but it's a massive first step in machine learning. Our code kicks off with the moment of birth, the init method. Think of this as the neuron being created in a state of, well, perfect ignorance. Its internal connections, which we call weights, are all set to 0. It knows absolutely nothing. We also set a learning rate here, which is basically a dial that controls how big of a step it takes when it tries to correct a mistake.
Now, take a look at the actual code. See that line that defines self.weights? You might notice it says input size plus 1. So if we have 2 inputs, we're creating 3 weights. Why? Well, that extra weight is something called the bias. You can think of it as a baseline nudge, a tendency for the neuron to fire or not fire even before it looks at the inputs. It's like its own little internal thumb on the scale.
So how does this neuron actually make a decision? That's what the predict method is for. It takes all the inputs, multiplies each one by its special weight, and then adds all of that up, including the bias. If that final grand total is greater than 0, it fires, it spits out a 1. If not, it stays quiet and gives a 0. It's a really simple, decisive threshold. Let's see how this actually looks in the code. You can see the logic right there. The summation starts with the bias. That's the very first weight in our list. Then we loop through the actual inputs, multiplying them by their own weights and adding it all to the running total. And that final line? That's the sharp decision point. Is the sum positive? Yep, return 1. Nope, return 0. Simple as that. And this brings us to the absolute heart of the whole process, the train method. This is the sacred learning loop. We're going to show our neuron the same examples over and over again, in cycles that we call epochs. And with every single pass, its initial ignorance gets slowly but surely forged into real knowledge. Inside this loop, for every single example we show it, the neuron does this little 3-step dance. First, it predicts, it makes its best guess based on what it currently knows. Second, it calculates the error, which is just the correct answer minus its guess, super simple. And third, it adjusts. It uses that error to tweak its weights, nudging them in the right direction. Predict, measure, adjust. That is the rhythm of learning.
The incantation is complete. Our logic is all defined, so now it is time for the invocation. We are going to execute our script and witness this process of learning with our own eyes. We're about to watch a machine achieve a form of gnosis, real earned knowledge.
So, head back to your altar, the terminal. Just make sure you're in the same directory where you saved your perceptron.py file. At the prompt, type Python perceptron.py and hit enter. The ritual begins right now.
Whoa, look at this. This is the moment of creation right on your screen. The initial weights are all zeros, a total blank slate. Then it sees its first tough example, input 1, 1. With its zeroed out weights, it guesses 0. But wait, the correct answer is 1. It was wrong. The error is 1.0. And look what happens immediately after. The new weights are not 0 anymore. They've been nudged up to 0.1, 0.1, 0.1. That right there, that's the very first spark of learning. As you watch the output scroll, you'll see this beautiful rhythm emerge. When the error is positive, meaning it guessed too low, the weights get nudged up. This means it a little more likely to fire next time. When the error is negative, meaning it guessed too high, the weights get nudged down to make it less likely. It's this constant corrective dance between being wrong and getting better. Let that sink in for a second. This isn't just numbers changing on a screen. This constant adjustment of the weights is the physical manifestation of learning. The neuron is literally changing its internal structure, its own mind, if you will, to build a better model of reality based on the data it's seeing. And after just a few of those epochs, the training is done. Our program then runs a final exam. And look at that. For every possible input, its prediction perfectly matches the expected output. It solved the puzzle, starting from a state of total ignorance through a simple process of trial and error and correction. It has learned the AND gate.
So what was the magic that just happened? What kind of complex wizardry was powering all that learning? Well, let's pull back the final curtain and reveal the mathematical soul of our perceptron. I think you're going to be surprised by just how elegant and simple it is. This is it, right here. The entire process we just witnessed, all the mistakes, all the corrections, the slow dawn of understanding, it all boils down to this single, beautiful equation. This is the perceptron learning rule. All that intelligence we just saw, it's right here.
And we can translate this into plain English pretty easily. The neuron's new weight is just its old weight plus a little nudge. Okay, so how big is the nudge? Well, it's proportional to the error. If it makes a big mistake, it gets a big nudge. It's also proportional to the input that was happening at the time, because that input has to take some of the credit, or the blame, and our learning rate. That's just the master dial we use to control how big these nudges are overall.
You know, when you really boil it down, this isn't just a machine learning formula. It's a pretty profound philosophy for any kind of learning, really. Admit when you're wrong, figure out by how much, and then adjust your own beliefs in proportion to your mistake. It's a blueprint for adaptation.
Today, we created a single spark. We took an idea and we forged it into code that actually works. But this one neuron, governed by this one simple rule, is the fundamental building block. It's the atom of AI. From this, entire cathedrals of intelligence are built. Which, of course, leaves us with the ultimate question. What happens when we take this first, simple spark and connect millions or even billions of them together?